We're on lesson 7 of chapter 8, which we're going to factor special products. So first we're going to factor the difference of two squares. Then we're going to factor perfect square trinomials. Then we're going to solve a real-world problem. So if you haven't noticed by now, these special products we're looking at deal with perfect squares. The first pattern we're going to look at is the difference of two squares pattern. So if you ever see a squared minus b squared, or numbers that could have a square root, there's actually a very simple factoring that takes place. You have a plus b times a minus b. Let me give you an example. You have 4x squared minus 9. Both of these have a square root. So that could be a squared minus b squared, which would be 2x squared minus the square root is 3 squared, which would translate to 2x plus 3 times 2x minus 3. Let me explain that a little more. You'll notice that there's an x squared and then there's a 9, but there's no x. Well, the reason behind that is because of the sum and difference. We have positive 3 times positive 2x, which makes positive 6x. Well, then we have 2x times negative 3, which gives me negative 6x, and they cancel each other out. So whenever you see that it's missing that middle variable, it's going to be the sum and difference pattern, a plus b times a minus b. So let's practice this one with some of these problems. We have y squared minus 16. So if y is my a and 16 is my b, I know it would be a plus b times a minus b. So the square root of y squared is y. The square root of 16 is 4, so it would be y plus 4, and then y minus 4. The 4 times the negative 4 would give me negative 16. The y times the y is y squared, and then the 4y and the negative 4y would cancel out. Now I have 25m squared minus 36. So if this is my a and this is my b, I can make this work as well. Square root of this would be 5m, so it would be 5m squared minus 6 squared. So I could do the sum and difference pattern. It would be 5m plus 6, 5m minus 6. 6 times negative 6 is negative 36. 5 times 5 is 25. Then the positive 30m would cross out with a negative 30m. Now I have x squared minus 49 times y squared. So if this is my a and this is my b, I would have x, which is squared, minus 7y, which is squared. So if we did the sum and difference pattern, it would be x plus 7y, then x minus 7y. Now I have 8 minus 18n squared, and you might be thinking, wait a minute, 8 isn't a perfect square, and neither is 18. But notice that they're both factorable. If I factor out a 2, for example, I would have 2 times 4 minus 9n squared. And suddenly I have two perfect squares. This is my a and this is my b. This would be 2 squared and then 3n squared. So if I keep this 2 on the outside, I would have 2 plus 3n and then 2 minus 3n. And this would be my factored square difference. Going back to the first page, we have perfect square trinomials now. You'll notice that these are perfect squares, a plus b squared, a minus b squared. Well, when you have a plus b squared, it turns into a squared plus 2ab plus b squared. So for example, if I have x plus 3 squared, the x's would be squared because they're going to multiply times each other. The 3's will be squared because they're going to multiply times each other. Then you're going to multiply this twice, which would be 3x times 2, so 6x. When it all comes down to it, it's a squared plus 2ab plus b squared. The perfect square, when it's a negative square, gives you that minus 2ab. And that makes sense too. You have positive a times positive a, which gives you positive a squared. You have negative b times negative b, which gives you positive b squared. When you do this multiplication, you get a negative ab and then another negative ab, which gives you negative 2ab. So when you work with this x minus 5, you have x squared, you have 5 squared, and you have 2 times 5x, 5 times x. And that's going to be negative. So when you solve all that, you have x squared minus 10x plus 25. So let's see if we can solve this. When you're factoring polynomials and you notice that there's a square here and a square here, so the square at a and b, that means it's a perfect square trinomial. So what you can do is you can find the square root, which would be n, and then which would be 6. And since this is negative, I know it's going to be a negative perfect square. So I can do n minus 6 squared. You can always check your work by saying negative 6 times n would be negative 6n, times 2 would be negative 12n. So that does work out. Here I have a perfect square, 9x squared, which would be 3x. I have a perfect square here, which is 2. I see the negative AB, which is negative 12x. So that means it's going to be a negative perfect square again. So it's 3x minus 2 squared. A times b, which is negative 6x times 2, is negative 12. So I checked my work again, and we're all right. Here I also see perfect squares. I see 2s, and I see t. Since we're adding here, that would be 2s plus t. That would be my perfect square, and I square that. Checking my work, 2s times t. Checking my work, 2s times t would be 2st times 2 would be 4st, just like that says it will. Now I have negative 3y squared plus 36y minus 108. So here I have a negative a, and I don't like to work with negative a's, just like that one last lesson we did. So we can get rid of that. And since all of these can be divided by 3, let's factor out that 3 as well. So divide everything by negative 3. This would become y squared. This would become negative 12y. And this would become positive 36. And now I notice I have perfect squares on both sides, which works. Square root of this is y. The square root of 36 is 6. And since the AB is negative, it would be y minus 6 squared. If you check your work, y times negative 6 is negative 6y, times 2 would be negative 12y. Let's solve a real-world problem. It says a window washer drops a wet sponge from a height of 64 feet. After how many seconds does the sponge land on the ground? So here we could plug these numbers into the vertical motion model that we've used before. We have h equals negative 16t squared plus velocity times time plus the initial height s. So it says the window washer drops it from a height of 64 feet, so that's where it starts. So this becomes 64. Since he dropped it instead of throwing it, it actually means there's going to be no velocity at first. If he would have thrown it, then we would have had to calculate that velocity. So it's actually going to be 0 for phi. And we need to find when this lands on the ground, which would be 0 for height. So if we rewrite this equation, it would be 0 equals negative 16t squared plus 0 times t, which equals 0, so I'm just going to leave that out, plus 64. So since I have a negative a and I don't want that, I want to factor out that negative 1. But while I'm at it, I see that 16 and 64 both have that common factor of 16. So let's factor out negative 16. That's going to leave me with t squared minus 4. And that's going to equal 0. If you remember back to our first problems, when we had that sum and difference pattern, that leaves out any of that middle t. Since I don't have any middle t and these are perfect squares, I could find the square roots, which would be t and then 2, and do that sum and difference. So it would be t plus 2, t minus 2, and then we have negative 16 here, and then we have 0 here. This negative 16 doesn't matter because if one of these is 0, that multiplying times negative 16 is not going to make any difference. So we can kind of forget about that for now, which I'm just going to erase it. So if t was negative 2, this would become 0. If t was positive 2, this would become 0. Since we can't really have negative seconds, it would have to be 2 seconds for that sponge to fall and hit the ground.